Okay, the second lesson in our matrices unit deals with addition, subtraction, scalar multiplication, and matrix multiplication, the basic operations with matrices. This lesson will be split into 2 videos so that you don't have to necessarily watch the entire lesson if you have problems with one or the other skill. The first video here is going to deal with addition and subtraction as well as scalar multiplication, because those 2 skills are usually found hand in hand in the same problem. So, whatever 2 matrices we are trying to add or subtract, there is a property that has to be true. So anytime that we try to add or subtract 2 matrices, those 2 matrices must have the same dimensions. They must be the same shape. If they're not, you cannot add them. And if you cannot add or subtract, then you would simply answer with no solution, or the null symbol. Other than that, this process is relatively simple. Here we have a matrix A that is 2 by 2 and a matrix B that is 2 by 2. The first problem here asks us to do A plus B. So normally they're not going to be written next to each other in such a nice manner, so I do always suggest that you start off by rewriting the matrices that you are actually working with next to each other. So in this case we have the matrix 2, 3, negative 2, 5, which is matrix A, plus the matrix 3, 5, negative 2, 3, which is matrix B. Now this is a very, very simple thing. All we do is we add the numbers that have the same row and column locations. So for instance, 2 plus 3 is 5. And we do that for each location. So we add 3 and 5 together. 3 plus 5 is 8. We add negative 2 and negative 2 together. Negative 2 plus negative 2 is negative 4. And finally, 5 plus 3 is 8. So A plus B would be the matrix 5, 8, negative 4, 8. Subtraction works exactly the same way. We're going to take those matrices, 3, 5, negative 2, 3, minus 2, 3, negative 2, 5. And we're going to subtract them location by location. So, 3 minus 2 is 5. 5 minus 3 is 2. Negative 2 minus negative 2 is 0. And 3 minus 5 is negative 2. Same thing if we were to, the only difference is if we reverse them, subtraction is not commutative. Meaning A minus B is not the same as B minus A. So when we do it the other direction, we're not going to get exactly the same answer. So 2 minus 3 would be negative 1. 3 minus 5 would be negative 2. Negative 2 minus negative 2, that's still 0. And 5 minus 3 is 2. Alright, scalar multiplication. A scalar is a number that is not contained in a matrix, and it's usually to show repetition. Okay, we can also show dividing up information using a scalar. So a scalar is just a number that's not part of the matrix. And it is actually a really simple idea, because when we multiply a matrix by a scalar, all we do is multiply every number inside that matrix by our scalar. So if we did 1/2 times A, that's 1/2 times the information located in matrix A. And all we do is we multiply every single number by 1/2. So that would be 2 times 1/2 is 1. Negative 1 times 1/2 is negative 1/2. 1/2 times 1/2 is 1/4. 0 times 1/2 is 0. 0.5 times 1/2 is 0.25, or 1/4. And 3 times 1/2 is 3/2. Now you don't know what you're thinking, Mr. Wills, how come only one of those numbers is a decimal? That bothers me. Well, if you want to turn that into a fraction, I'm okay with that. What I'm not okay with is I'm not okay with you turning things that are already fractions into decimals. So you either need to give me the answer as a fraction, fully reduced, could be improper but has to be reduced, or if it started as a decimal, it can stay a decimal. So if you replace this 0.25 with a 1/4, I'm okay with that. But I'm not okay with you replacing this with 0.25. Hope that makes sense. All right, let's do some more examples. -2 times a. Again, all we're doing is taking the information in a and multiplying all of it by 2. So that would be -2 times 2 is -4 by -2, not by 2. -2 times everything. -2 times -1 is +2. -2 times 1/2 is -1. -2 times 0 is 0. -2 times 0.5 is -1. And -2 times 3 is -6. Finally, 5a. Again, we're just going to do 5 times each number in matrix A. 5 times 2 is 10. 5 times -1 is -5. 5 times 1/2 is 5/2. 5 times 0 is 0. 5 times 0.5 is 2.5, although you could write that as 5/2. 5 times 3 is 15. Now that's it for scalar multiplication, addition, and subtraction. However, we are going to do one more page worth of examples because it is very rare that you will only see one or the other. Usually you'll see them combined. And in the case of seeing scalar multiplication and addition and subtraction in the same problem, you simply follow order of operations. Remember that order of operations states that multiplication is supposed to happen before addition and subtraction. So for instance, here I have 3 times b minus 4 times a. So let's write out what that's saying to do. We're doing 3 times the information in matrix B minus 4 times the information in matrix A. 3, -2, 1, 0. Order of operations says that scalar multiplication should come before addition or subtraction. PEMDAS, right? Multiplication division is before addition subtraction. So we're going to start off by multiplying all these numbers by 3, which would be 15, 0, 6, 9. And I'm going to leave this as a minus, although you could do -4 times this matrix and then have a plus in here. It doesn't matter. You get the same answer either way. So I'm going to leave this as subtraction, and I'm just going to multiply everything by 4. So 3 times 4 is 12. -2 times 4 is -8. 1 times 4 is 4. 0 times 4 is 0. And again, if you did -4, then that simply makes this addition, and all these signs would be reversed. Then we do what we did on the first page. We're going to go through and we're going to subtract location by location. So 15 minus 12 is 3. 0 minus -8 is 8. 6 minus 4 is 2. And 9 minus 0 is 9. So 3b minus 4a is the matrix 3, 8, 2, 9. That brings us to our bottom example here, 2c plus a. Now we normally would do the matrix or the scalar multiplication first. However, we don't need to do even that much, because if you look back up at the directions, C and A are not the same shape. C has 2 rows and 3 columns. A has 2 rows and 2 columns. They're not the same shape. And if they're not the same shape, then we cannot do this problem. We could do the scalar multiplication, but we would not be able to do the addition that follows it. So we're saying that this is null because C and A are not the same shape. So this problem is not possible. Hence why we are answering with the empty set no solution symbol, which is null. Alright, that does it for scalar multiplication, addition, and subtraction.